Dave here, how are you? Today we're going to play around with the CNC, but mostly we're going to be looking at Aspire by Vectric, and that's the software that tells this machine what to do. I'm showing you this position here on the machine to let you know about one thing before we start. The machine has its absolute 0 points. So it is right up the top. See the green sensor here? That's for its Z-axis. That's a 0 for there. So over there is the Y-axis, which is the length of the machine. As the gantry is coming forwards and backwards, 0 will be as far forward as it can come. And the X-axis, which is the gantry's area where the spindle travels left and right, is right out on the end there. See that green sensor there? That's its, and there's one just behind my neck, just here. This is the other side. That's all the way out the other direction. There's other things here. This machine has also got another one down here. I don't know if you can see that. I'll swing around. There it is. It's behind me. So that's its slave Y. All right. It might sound a little bit crazy, but you know, it just makes sense. It says you can't go any further that way. You can't go any further this way. And I'm taking you right up out of harm's way in the Z-axis. And that's where it homes. You'll see here I've got it parked on my job 0. So the job 0 is my X across here. That's, I don't want the machine to go that way any further. And I don't want the machine to come towards me any further. That's where I would anchor this part, this melamine, if I was to actually do a job with it at the moment. I have another camera set up over here, and you can watch on this screen on the laptop that tells this what to do. Okay, I'm going to tell it to ref all home, which means it's going to travel up, travel forwards, and park itself in the corner. There she goes. And up she comes, nice and quiet. I haven't got the spindle spinning. I won't do any spindle work today. I'm just moving the gantry and the spindle around the job. How cool is this? It's going to go over there. Nice. Lovely. Now I'm going to switch screens and we're going to go into the software, and what I've been talking about might make a fair bit of sense. Now this is Aspire put out by Vectric. Now Aspire is a very, very powerful program, and I'm only just scratching the surface with it at the moment. I do recommend you go to their tutorials if you're interested in getting Aspire, because they are fantastic. They were such a help for me. But again, sometimes there were some things that were kind of taken as a given, and I was struggling a little bit here and there, but overall they were fantastic. Now, what we have here is very easy. This is just your standard file, a new job, open an old one, and there's probably some that's been happening that I built recently. Gadgets, I haven't even gone into gadgets. There's a truckload of stuff there. Help, and this was pretty good. There was a couple of things here I asked its help, and it was pretty good in giving me an answer. So I'm going to create a new job. Now I'm given a few things down the side here. Single-sided, we'll stick with that. We're not doing any fancy stuff where we're turning the boards upside down. That's further down the track for me. So the first part, we just leave it alone. The next part, we have the width, which is our X-axis, and our height, which is our Y, and the Z is the thickness of the material and what type of units we're going to go, inches or millimeters. Now, I'm metric, so I'm going to stick with millimeters. Down here, you'll see the 0 position. Either it lets me have the material surface or the machine bed and where we're going to be starting from. I could tell it to start from the middle, and you can see straight away it's put that red dot. So that's its 0 point. So everything up this way would be a Y positive, everything below that line would be a Y negative, and everything to the right of that line would be an X positive, and this way would be an X negative. I've set the modeling resolution at very high because this computer can handle it, and the appearance you can have as solid color or all different types of timbers. It's not going to show you any of those until we go into a 3-dimensional view. So in 2-dimensional, whilst we're in CAD, which is what this is, computer aided drawing. Now I'm going to start at the top and we're going to work down. Forget this part, we'll go to the job size. So we will switch back over to me and I'm going to measure this piece of melamine that I've got sitting on the bench, on the spoil board. That's 589 and it is 357. 589 by 357. I'm going to write that down. So the width was 589. I'm just hitting the backspace button there. 589 millimeters. And then the height, again, backspace. Or I could select all of it and just leave it cursed, leave it like that, and type in, and I think the height was 347. So I'm just going to type in 347.0. And now you can see on the screen here, that's the sheet that I've got on the bed. Now the thickness, I know it's 16 millimeter melamine, so I'm just going to type in 16.0. Now why does it want to know the thickness? Well, because I'm going to tell it to everything will be from the top. And if I tell part of its job to be, I want you to drill down through the surface 16.1 millimeters, it's going to throw up a warning and say, Dave, are you sure? It's not actually going to say my name, but you get the point. It's going to say, I'm going to go right through this material and into your bed here if you're not careful. What do you want me to do? Is that okay? Now, it is for me because this is a spoil board. This is designed to be cut into, not going into the aluminium 4080, because I don't want to chop into that. That's what this is all about. This is my sacrificial board that it sits on and anchors it in position. So let's slip back to here again. Now, I'm coming down to my XY datum position, and I'm going to say in the corner, because then everything is a positive Y and positive X out to the right-hand side. Back to me. There's my starting point on my job, not the machine's zeros. Machine zero is over there. This is the job zero, and it will understand that. It does. It's smoke and mirrors. Don't worry about it. It knows how to do it. And then this is my X width and my Y length dimension, and the thickness is 16 millimeters. This is great. It's so easy. If you're struggling, stop the video and start again. It's pretty easy. Here we go. I'm going to switch over to the next part now. We'll have a look. Now we'll go with solid color, will be fine. Okay, let's say okay. And now we are presented with all of these options, these tools that we can use. Now one thing that I'm going to do right at the beginning, one thing I'll tell you now is if you want to see the job smaller or bigger, you use this guy, the scroll wheel on the mouse. Now it's got a few purposes. Pushing forwards and pulling backwards is going to change. It's going to make it smaller on the computer or larger on the computer for you to see. If you push down on the mouse and then drag the mouse left and right, that will pan over the area you're on, rather than having to, click on the sidebars and pull them down and click on the bar at the bottom and drag it across and try and get it in the position. It's too slow. So we'll go back here and have a look. These are little things I pick up as I'm going. Now I'm going to scroll away. That was the wrong way. I'm going to scroll towards me, which has made the job look smaller. And now I'm going to push on the mouse and drag. Now, all I've done was push down on that scroll wheel and drag it around. So that lets me pan around it. I'm going to make it bigger by pushing away. And now I'm going to create a vector. This is the part everyone's been panicking about. I'm going to create a circle. So over here, create vectors. I'm going to create a circle on this job. And the center point, I've got 50 millimeters and 50 millimeters. Let's make it 70 millimeters to the center point along the X line. So see it now, the cursor has got numbers popping up beside it, 70.01. Well, that'd be the slack way of doing it. Wouldn't it be better to tell the machine, or tell the software, I want it to be exactly 70. And let's leave that at 50, that'll be fine. And the radius of the circle, let's make it, oh sorry, the diameter, I can do either radius, and it's got a little picture up there that tells me what's happening, or the diameter. Let's go to the diameter and we'll go, let's say, 30 millimeters, 0.0. I know they like saying put 0.0 in there. Now when I click create, it's going to put one circle down here somewhere. And it's going to be perfect. You watch, create, and there it is. Now I'm going to click close. And I can scroll on my mouse again, away or closer. Oh, I've lost the circle. Where's it gone? I'm going to push down on the mouse scroll wheel and drag so I can see where it is again. That's pretty cool. That's a vector. Now, that's just now at the moment, that is a black circle and it's not going to do anything. If I want to wake that vector up, I left click on my mouse and drag over it. And now it's a dotted red line, which means that vector is wide awake and I can do things to it. Well, what I'm going to do is I'm going to click away from it again. I've clicked over there somewhere and it's put the vector back to sleep. I'm going to create another vector, another circle, and I'm going to tell it I want a circle over here somewhere, and I want the center to center to be maybe from there, this way I want it to go 70 millimeters. So I'm going to say 70 and 70 will be 140. Does that make sense to you? And the same radius, and create. And there you go. I have a second circle. What I'm going to do next is I'm going to join those two circles with straight lines. And I'm going to end up making a slotted hole. Now, why would I want a slotted hole in a job? Well, maybe I want to be able to slide a clamp head up through it. Maybe I want to make something like a drill press table. And I want a couple of slots that the clamp heads can come up and I can hold onto things. And I just thought of that. Okay, here we go. This is so easy. Now I'm going to go to this line here, which is create a line or a polyline. Now I don't have to touch anything in there if I don't want to. I can click on it. So I'm going to click there, and drag a line across, and click there. Now I'm going to do something else that a lot of people won't tell you to do. I'm just going to drag it down, and I'm going to click there, and I'm going to drag it across until it finds it. Now it's actually snapping. It's snapping to that, and I'm going to come over to there. It was snapped to the tangent. It made it a tangent to that circle. I'm going to hit close, and that will now disappear. And I'm left with these figures here. It's pretty easy now for me to go over and get the scissors. See this? I'm going to click on those, and I'm going to say, I don't want that part of the circle. I don't want that line, and I don't want that part of the circle. And now I can click close. Now I have a slotted hole that's the dimensions that I wanted. I'm not going to do any more today. That is enough. I don't want to show you too much. I'm going to keep on going on with this, and then we're going to eventually create a new spoil board, and we're going to square this machine up. I've calibrated it okay, but it's still a little bit out. There's a very easy way of doing that, and we'll actually use the machine to look after that. I'm going to drive this around a little bit more. I like to drive it. That's just so beautiful. Don't you reckon? Thanks for watching. Keep on coming back. Give me a thumbs up, subscribe to the channel, share this video with people who you think may be interested in following my journey into CNC, the world of CNC. And thanks again to Vectric, and also thanks again to CNC Router Parts. Bye.